Okay, this video is about how to do redox titration. Okay, the first thing that you got to do, I don't want that, let's see here. First thing you got to do is to balance this redox equation, and the best way to do it when it's in this net ionic form is to write the oxidation and reduction half reactions. So what you have to do first is you have to kind of go up here and you have to figure out the oxidation numbers. So now this whole thing, it's kind of a key thing here, is this whole thing, this whole ion is -2. And so we know that oxygen is -2, so that's going to be -14. So that makes this chromium has to be +6 to be +12 because net it's -2. All right, and so the rest of the things all have the oxidation numbers good enough so we can do it. So the first thing is we're going to look for how they change. So we're going to take iron, and iron is 2 positive, but it's +2, the oxidation number. And then it goes to +3. So we're always going to add the electrons to the more positive side. And so that's +3. And so we have to add 1 electron to make it balance out. And when the oxidation number goes up, that's the oxidation half reaction. Okay, then we're going to do the chromium because it goes from +6 to +3. And so we're going to go chromium. But before we just write chromium, we have to put the subscript, so it's +2, and it's +2 there, and it's +6 there. Okay, we figured that out up above. All right, we're going to need to leave room for electrons on that side, and so then it's going to go to chromium +3 on this side. Before you do the electrons, you have to balance this little mini equation by putting a 2 there. So 2 times 6 is +12, if you do 2 times 6, and 2 times +3 is +6, so the difference between 12 and 6 is 6 electrons. So you have to add 6 electrons there. Okay, and so this is the oxidation number is going down, it's being reduced, so this is the reduction half reaction. So now the rule is the electrons lost must be equal to the electrons gained, which they're not, so we have to multiply this whole equation by a factor of 6. Now once we do that, because 6 times 1 is 6, and that's 6 electrons. Now once we do that, we can balance this. So we need 6 Fe's there, we'll need 6 over there. We've got 2 CRs here, we're going to need 2 over here. We've got 7 oxygens here, we're going to need 7 over here. That makes 14 hydrogens there. So the ratio between this iron and this chromium ion thing is 6:1. Okay, calculate the grams of iron in the water sample. Okay, well, anyway, we know how much of the sample we got, but what we need to do is we need to use this titration data. So the titration took 32.26 milliliters of the chromium stuff. So we'll write 32.26 milliliters of it. But remember, whenever you take the milliliters of something times its molarity, and its molarity is 0.0163, and it's the molarity, you can change that to moles, and that's the KCr2O7 for 1,000 milliliters. Because remember, a molarity can be broken down into the moles per liter or the moles per milliliter. And so whenever you take the volume of a solution times its molarity, broken down in this form, you get moles. So there, I just changed to moles. Now I'm going to do the mole ratio. The mole ratio is 1 mole of KCr2O7 to 6 moles of the iron. And then I could just change iron to grams. That's how I'm going to find the iron. So 1 mole iron, and the molar mass, if I go out several digits, is 55.847 grams iron. And so that ends up being about 0.1762 grams of iron if I solve all that. Now to do the mass percent, you basically just take the mass of your iron, 0.1762 grams iron, divided by the mass of your water sample, which is 1.27 grams water, times 100, and I end up getting 13.9% if I did the math correctly. All right, so when you're trying to find a mass percent, you basically have to take the titration data, which will be the volume it takes to not neutralize it, but to react with the iron, and so you have to use its molarity to change to moles, mole ratio, and then change to grams, and then take the mass of whatever substance you're looking for, the mass percent, divided by the whole times 100. Okay, that's it on that video there.